our possible best, and then see whether if we can finish with statement in R, and of course, so that we can go to loops. Look at, so today we'll be looking at, if we have time, we can look at nested if. They are very important. That is one of the basics when you start to write code. You are writing code to do something for you. If we don't get that, we may find it very difficult to be able to get. Okay, we'll find it a little bit tougher to be able to get this part. But before we do that, yesterday I said I was coming to, when I come, I will try and then throw a little more light on arrays. So, and this was where we ended yesterday on array. So, I think the point was quite simple. We're all getting tired. So, arrays simply, we got to know that it's just the same as the way we have matrices, but it's like you are representing matrix more than one different times at different times. So if you have a matrix, matrix 1, matrix 2, matrix 3, or you want to represent them at different instances, then you use array to be able to do that. And arrays are very good because they help us to be able to create different groups of data and analyze them accordingly. You can use variability and intervariability. Somebody was asking me today, I think it's Eben, about how do we apply R in science. We are coming to that. What I just mentioned now is one of the things we apply in when you are doing microbiome studies. You actually want to know the intravariability of the microbiome. If you have taken a microbiome of, let's say, the gastric system, or maybe you just want to measure the different microorganisms that are found in different parts of the human body. You could check the armpits, check the mouth, check the nostrils. Of course, if it's possible, you could check the eyes. Then you could check the hair, check other parts of the body where you think that maybe we accumulate some microorganisms. Then we could try to isolate them and see who they are. And then we could try to check their variability. So we could check the variability of all the microbiome within the armpits. We could check the variability of all the microbiome within the mouth. And even within the mouth, we can check in different parts of the mouth. We can take buccal swabs and then we go to the lab, try to isolate the microbiome, and then we try to do this comparison. R is very good at doing that. What is it? We have all this, what the Bricaceae and whatsoever, their distances, and R has all those things. What is where we can have the opportunity to do all these things. We will get to, maybe getting to tomorrow or tomorrow next, we'll get to a topic that is that has to do with statistics in R. And when we do PCA, we can see how we can use R to actually group these organisms based on intervariability and intravariability. And I think it will be one of them. We also can use R in GWAS studies, genome-wide association studies. I think is a whole topic that my boss, so I've already prepared the slides. So, but one of the basic thing is that we know that genome-wide association studies, you are just trying to look at the frequency at which a gene occurs, which is associated to a phenotype. You've seen that there are people who are tall and people who are this, so you just try to pick their samples, you sequence them and have their SNPs. You can call your genotypes and then begin to do your comparison. You want to compare the genotype to the phenotype, and to do that, R is very, very efficient. I've actually used R to analyze it. What I'm going to teach, I've already analyzed the data, the 5 differences of the data, which is lying there. I'm just waiting for when school opens. That will be my assignment. I'll be giving to them to do it. So as we go, when we have more time, we are not just going to be doing these things. We will try our best and then pick specific topic and then come and then make sure that we use R to analyze it. Let me also say another application of R in science is when you are doing meta-analysis. R is very efficient when you are doing meta-analysis. What R is not able to do in science, as far as my area is concerned, is if you have your DNA, if you have extracted your DNA and you've gone to do the sequencing, when you come, there's something we call quality checks and cleaning the data. R can only clean statistical data, but genomic data, we use command line, Unix, to be able to do that. So that one, we are able to do our multi-QC, and then we can check the entire data to see where we need to cut some reads off, or we need to trim some reads, and we can have. But right after we've done that, the rest of the work, R can do it. And I've done that quite a number of times with R. So that's just by the way. Those are the few things where we can, but there are a lot that we can apply R in science. Every aspect of scientific analysis, R can do it. Now we can use R to build a database, SQL. If you know what SQL well, we can do that. Now R has incorporated a lot of different aspects. We have R in engineering. We now have R in architecture. And maybe I could actually just, maybe one day play, like that one may not be a class, but like play because we are not in architecture. But I could just use R and let us come out with a 4-bedroom plan. We are just going to put in some codes and then in for us. And you see how it is, 4-bedroom house. So we just need to indicate the plot size, indicate the room size, how many bathrooms we need, and do we want it at this geographical location? How many doors do we need? What kind of doors do we? When we have finished everything, we click run to print out the whole thing for us. So it's quite interesting. Okay, so today we want to look at what is it? Conditional statement. I don't know. The arrays, is it okay? Is it okay by you guys? Do you want me to say something more? Because this was all about the subsetting. I was saying that one you need to have 3 comma, the row, the column, and then the specific array that you want to actually pick up that subset from. That was what. There are other things, how to also add an array, how to remove an array. You can remove the entire array. You can remove some few portions in some of them and then leave others by using negatives and whatsoever. All of them will work. So if you have a question about that, then I can throw more light. If not,
we are not live, please.
We are not live. We are live. We've recorded for seven minutes now.
We are live. Okay. Normally I see the live sign on my screen, so I was wondering why it's not showing.
Maybe, I don't know, but over here it's showing me that we are live on the left hand side.
Yeah, it's also showing here. Also showing here, like.
It's not showing.
It's showing here.
Okay, all right. So let's look at statement, conditional statement. Very important. Conditional statement is the beginning of making sure that you are able to do what we call coding or script writing. Much of the things we do is about script writing. You write your own script to do the work that you want. But before we're able to get to that, let's look at the basics of conditional statement. And I want you guys to let's play along. There was this thing, I didn't say it, but I just noticed that like this is equal sign in basic mathematics. But it does not mean that when I say A is equal to 4, it doesn't mean that A and 4 are the same. Is somebody talking? In R, when you have one equal sign, it is called assignment operator. It means you are assigning something to the other. But it's not like in mathematics where we say x is equal to 24, which means x is 24. This one means that you have assigned 24 to what the variable. If you want to say, like the ordinary mathematics, where we say this is equal to this, then you use double. Equal. That's in R language. You use double equal sign. So if I say A is equal to A, it means that I'm saying that A and A are the same. If I say A equal B, it means I'm saying that the two of them are the same. That's what I'm trying to communicate. Now, if we want to find out whether, if we want to find out a percentage of something, we use the ordinary percentage, like this. If we want to find out n, to use the word n in conditional statement, there's something we call ampersand, shift and 7, ampersand. That means n. So if I want to say A and B, I'll just write A ampersand B. So it means I'm talking about A ampersand B. To get the ampersand, press shift and 7 on your keyboard. Then you will get that quite clear. Now, if you want to use OR in R, you use what we call the pipe operator. The pipe operator, you can find it on my keyboard. It is found, I'm using QWERTY keyboard, so on my keyboard it is found when you press shift, and there is a key close to 7 on the left hand side of 7 on the numerical side. You will see that sign, that particular key that has a very straight line. It has backward slash and then a straight line on top of it. So we use a second function to print it. That's OR. That is what we use to represent OR. Now, we use percentage in percentage to mean that you want to find out whether something is a member of something. Where do you belong? So if I want to find out, is Polly a member of this class? That's what I have to do. Then I have to use this particular algorithm to be able to do that. We also have percentage, greater than percentage, and this is also a different algorithm. It's a pipe operator. We use it in dplyr. We haven't gotten to that. We also have what we call the modulus. We have the modulus, and the modulus is like when you divide something, whatever is remaining, then that's what you are looking for. We use that to be able to find out whether a number is even number, is odd number, is a prime number, and then to be able to come up with a condition. We can say that maybe you have a data set that you want to find out whether if there are prime numbers in it. You can write your loop, and the loop will go through the data sets and go through and then find out any number that is even, it will print that number. If it's not even, it won't print. And you have to use modulus to do that, because when you divide any number by 2 and there's no remainder that number is an even number. If you divide any number by 2 and there's a remainder, it's the likelihood that it will be an odd number. There are ways to be able to identify that. So it will print all those ones out, and then that's what is used in designing traffic lights. I think that maybe as I talk, I should be mentioning the applications. If you don't do that, you won't get it right. But we will not jump the gun. We'll get to that place. So to begin with, conditional statement, you are just trying to make sure that you return all that you are returning is it true or it is false. So if I want to find out whether 23 and 233 are the same, I do 23. Then when you run it, it tells me that it is false. Let me clear the console and then make sure that I have it clear. So if I run, let's say 23 equal this, it's going to tell me that it is, no, I was not running. If I run it, it will tell me that it is false. It's not true. 23 and 233 are not the same. But if I also say, if I want a text, if I want to compare a text, I could say AA, then I could just, I think I have it already, then which is around here. Now you can also compare vectors. You could have a vector.
Big Red, sorry.
Yes.
Okay. So my network was disturbing me, but I think I'm back now.
Okay. All right.
I realized you said 23 equals to 23.
Yes.
Was false. But initially what I heard was that when AA is equals to AA, when you run it, you should get that.
True.
But I don't know why 23 is not giving us that.
No, it's 23 and 233. It's not 23. So if I remove the last three and they are the same, then it will give me true. It means that they are the same. So if I come here, this is the text aspect. I could say AA and then AA, they are the same. If you run that, that should give you true. But if I say AA and I put A and B, then let me run that again and you see, it says it's false. The result will be that it is false. Now,
okay.
If you want to say that, if you want to know if AA and then, or if you want to say something is not equal to, you use exclamation mark and then the equal sign. And then, so you see that I am saying that AAA is not equal to DDD, then it should be what? True. Then when it will return true. You may not see these things, they are used for now, but when we go to the conditional statement, you will see how very useful they are. Now, we can also write a mathematical equation and then find out whether the two equations are equal or they are not. We could actually do that. We could just say, maybe I want to know whether, if I want to know whether 6 raised to the power 2, let's say multiplied by 3, is it the same thing as is it the same as 6 times 6 times 3? Is it the same as 6 times 6 times 3 times 3? So I can just do that and run, and they say yes, it's the same. So you can put your equations on either side. If you want to weigh them, you just put this equal sign there, double equal sign, and it will tell you, it will return the boolean, whether true or false. Now, as we can see, we can use other conditional statement like if we have another one here. If we have, let's say, 23 is greater than, and in this case, let me emphasize this. Here, I am using a condition called N, and that's why I'm using the ampersand. You can see the ampersand symbol there. I said if you want to get the ampersand, Shift and 7 on your keyboard, you will get that. So you have 23 is greater than 12. Here you are given two conditions, and in programming, when you are using ampersand or N, it means that the two conditions must be met. They must be met. If one of them is not met, the condition will not be executed. So I'm saying that 23 is greater than 12, and then 34 is less than 60. It will return true because the two conditions have been met. But let's assume that I want to change one of the conditions to be, okay, let me leave it that way, copy and paste it. So if I change this condition to, let's say, greater than, it means one of the conditions is not meeting. So it should, the results will be that it is false. Because, but if I am using or, that's the pipe operator, or it means that I only require one condition to be met and the statement is true. I don't require the two statements to be true before it will be true. So if the first statement, if one of the statements is true, it will return true. If the two statement is true, it will return true. But if the only way it will return false is when the two statements are false, then it will return false. So let me come and run the pipe operator, and then you find out something. So you see that, what is it? It tells me that it is false. So what it means is that the two statements are wrong. For instance, 23 is not less than 12, and 34 is not greater than 60. But let me change one of the conditions and it will be meeting. And so you realize that that is going to change the statement to be true. So I could just put this there, and then when I run it, it tells me that it is true. Yeah, so that's how we use or and n ampersand to be able to detect. We can actually check this when we have, let's say we can actually use vectors to do this. So let's say I have a vector here. Let's say I have a vector of characters. So this could just be A. Then I could just have like D. I could just have something like C. So if I want to find out whether that vector is, let's say, whether that vector is a character or something, yeah, I could just try and do that. Maybe that's another. Or if I can find out whether that vector is the same as, let me create another vector too before I come to that. I could just say, okay, this is B. Then I have comma. I could just say D, and then comma. I could just say C. So I have C. Then let me run that and see. You see that it compares them one after the other. So the first one is false because A and B are not the same. But the second one is true, and then the last one is also false. Are you guys watching?
Yes, please. Yes, please.
Why do you think the last one is false?
Because the last one is a capital C.
Capital letter. Arrow is very sensitive when it comes to the order and then the uppercase and lowercase letters. So that's what the problem is. So if you want to compare a large set of numbers, you could actually use this to be able to do that. Now,
please,
yes. Come again.
I didn't get
Your line is a little bit faint.
Line 163.
1. Okay. Then I get you now. So I was saying that you have the condition from, let me start from line 159. So I was saying that if you have different conditions, two sets of conditions, and you want to find out whether the two sets of conditions are true or not, and you can use either n or, so in this case we are using n, and I'm saying that for n to be satisfied, you have to make sure that the two conditions met, they are true. If one of them is false, no, it won't work. And that's what it means. So I just illustrated it with what we have here, and we can see that 23, let's say, greater than 12. Yeah, it's true. And 34 is less than this. That's true. But so in that case, the statement will be true. But when we come here, and one of them is false, like 23 is greater than 12, and 34 is greater than, 34 cannot be greater than 60. So one of them is not true. In that case, that is going to be false. I just popped in with this one. I'm saying that you could also have tried vectors, different vectors, whether in characters or whatsoever. So I just give it with one of the signs first. That's the equal sign to find out whether they are the same. And I'm saying that they will return, They return false, false, false. Let me put any of the the other sign there and then see what will happen. Let's say I put this there. I don't know if this will work. It won't work because it's not a mathematical operation. So it's not able to evaluate. So this one, you can only check whether they are the same or they are not the same. So it's not going to perform any mathematical operation. So, and when you come to the pipe operator, that's how you can also check. With the vector, you could also check for numbers. You could check for numbers. You could have different set of vectors, and then you try to find out whether the vectors have the same entry or not. And then here we are using the pipe operator. To get the pipe operator, shift and a key close to 7 on your numerical keyboard, and then you can see the pipe operator there. It's just like 1 over there, and that means OR. For OR, you need one condition to be met, and then that's all. Now, when we come here, when we come to this place, this particular symbol you see here is what we call a member of. This is an ordinary English. Member. You want to find out whether something belongs to another thing. Okay? So, what you do is percentage in percentage. So, you want to find out whether whatever character that is here.
I want to ask a question about the pipe operator first.
Yeah, go ahead.
Can we use it to analyze characters, like two vectors?
What is it? Is a mathematical operator. It's kind of a mathematical operator. So what it does is it has to be able to evaluate whether what is on the left and what is on the right mathematically or numerically is the same or not. So that's what I know. So this or this. Okay? So you see that when you come to the the pipe operator, we are using mathematical operations, or we are using mathematical formula, because we have already given one condition on one side. Like 23 is greater than 12. Is it true? Then this and this is this. Is it true? So maybe around here, we could have said that is the vector a character? Or we could say the vector is a character, or the vector is not a character. That way, if the conditions are met, it will work. But if you are using it with characters, I'm not too sure it will work. I haven't tried it, but I'm not sure it will work. For instance, if I come here and I put the pipe operator there, I'm not too sure if I run it, you see that it won't work. They tell you that it's only for numerical. And that's what I like about R. When you make a mistake, they tell you, when you go to the console and read, they tell you that the operations are possible only for numeric or logical or complex types. Complex types is when you have, let's say, 5i plus 4l. These are inbuilt codes. And so we call them complex numbers. So that's how it is. It won't work. It works for only numerical. And we just have to know that. Okay, so here we are trying to find out a member of. I want to find out whether this name, Paulina, is a member of this particular group. Or is she found in this particular group? So I could just run that and they say it's false. It's not found there. Paulina, if you are watching, why do you think your name is not found in that set or in that group? Line 166. Or she's offline. She's around.
Yeah.
She's online. I think. Yeah.
Come again. Paulina.
Yeah.
Today your network is bad or what?
I don't know. I'm saying that you started the
That's all. Yeah, that's great. Yeah, that's great. Because your name here is spelled with small letters. Here is spelled with capital letters. Okay, so your first something you need to do before we go to the next section. Before you go to the next section, I want you to find out whether here we are looking at Paulina. We want to find out whether Paulina is a member of this class. Now, what I want you people to do is that find out whether Paulina and Eben are members of this class using the same analogy. I want to see something. Do you get it?
Yes, please. Yes, please.
Yeah. So do that and let's see what you're going to get. Find out whether the two people are members of the entire class.
Should we use the small Paulina?
No, you are going to write the entire yourself. Any way at all you want. I just want to see that the code has run and the color is blue. Whichever way you want to, just do it. Mohammed, you're welcome. Oh, he's off again. Notice he's back online. Is anybody done?
Yeah.
Great. So, tell me how you did it.
I just have see like the Catholic function. The right Paulina Evelyn maintaining the symbol. Another Paulina Evelyn.
Okay, great. Yeah, that's it. All I wanted you to do is to use a vector. You have to create vectors of one of them. So you just would start with a vector like this, and then you enter the vector and then just write. So you have this. Then when you come out, you just have to write the other person, and then what is it? That's all. Now when you come out of the vector, then you are trying to now look for the set of people in another vector. So you just copy this here. You copy. I'm just going to copy that there and come and fix it down here. So I want to find out whether these two people are in this or not. So when I run, they say false and true. Paulina, what did you get?
Yeah, I had
True. Which means the spelling was accurate. But you notice that here Paulina is spelled with capital, then the other place it was spelled with small letter. So I cannot identify it. Okay. So there's another thing I've never mentioned it to you. There's something we call letters. This, and then I'm going to say 1 is to 6. And then I want to find out whether this is the same as I'm going to do this 1:6 and run that code and see what is going to happen. False, 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 false. Okay, yeah, so latest is a function. That's the function we use in printing A, B, C, D, alphabetical, right? So I think I wanted to mention it yesterday, it skipped my mind. So we want to find out whether 1, 2, 3 up to 6. That's A, B, C, D up to what? Let me go to primary school. A, B, C, D, E, F. So that's up to F, right? So if you had printed only one side, if you print this, you see that you can see A, B, C, D up to F. You print this side. So that's just to illustrate that capital letters and small letters are not recognized by arrow the same way. So if I want them to to be the same, I should have used the function in uppercase and then whatever. So I think you get it right now. Now let's move to another. So now I have a whole set here. So I could try and find out whether this set of numbers that I have, the set of numbers I have here, are there some numbers there that are greater than or that are equal to 3? So you give the entire vector and then you run it. Then 3 will be compared to each entry, because you remember you are using concatenate or combine function. Combine function means you've combined so many vectors into one, or you've combined so many values into one. So you are now going to use one value to compare to all of them. So 3 will compare to 3. That's true. The rest, it will be false, false, up to somewhere. So the second way, you can also say, what is it? You have 3 here, but you want to find out whether it is greater than or equal to 3. You can also use that. So 3, you will see here, it will be true. If I run that one, you will see the outcome. Almost everything there is true. All right, so second exercise. If you've done that second exercise, I want you to write the same kind of code here, but let's assume that you have a class of 10 children whom you have just scored right now. Write this same kind of code to indicate those who passed and those who didn't pass. You can use true to mean pass, false to mean fail, and then just do that right now and let me see.
Don't understand the question.
I'm saying,
please take it again, please.
I'm saying that we have the first entry here. We just use 3 here to compare to the rest of the entries in the vector. The second one, we've also used 3 to compare, but this time around we are comparing whether any of the entries in the vector is greater than or equal to 3. And so the results will come out as true or false. And I'm saying that if you wanted to know whether the results, or if you have children of 10, you have just given them score or pass marks. Like, let's come to science. Maybe you have recorded some people's temperature in the hospital. Or you want to find out those who have higher temperature. I mean, how will you write a simple code like this to be able to interpret that? And then you can isolate those that are having the higher temperature. Do you get it all?
I don't know if it was my network.
Okay, I was saying
I could hardly hear you.
Can you hear me now? Can you hear me?
Yes, please. It's better now. It's better now. Yes.
Great. I was saying that you are working in a hospital and you have picked the temperatures of some people. So you want to find out who and whose temperature are higher. So just use this same principle here to let me and print those whose temperature are higher and those whose temperature are lower. If you get it, you try. Okay. If you're not getting it, we'll do it together and you see how it's quite simple. Just use the true to mean that the temperature is high, false to mean that. So when somebody turns false, it means it's low. If it turns true, it means it's high. But I just want you to write Actually, you should have values that are representative. You know, temperature in Ghana, a normal body temperature should be 37 degrees or 37 degrees Celsius. So you can give your own range of numbers and set up your condition, and it will print those who are having higher temperature and those who are having lower temperatures for you. Are you guys done? Okay. There's no time, no time, no time.
I don't know. This guy,
Eh?
I created
I created
a
Uh-huh.
10
10
different
different
values
values
ranging
ranging
from
from
16 to
16 to
68.
68.
Okay.
That's a
That's a
vector of
vector
that.
of that.
And then
And then
I brought
I
the
brought the
greater
greater
than
than
and equal to
and equal to
37.
37.
Okay.
So it
So
printed
it printed
false and
false
trues.
and trues.
Then I
Then
copied
I
that one
copied that
again
one
and
again
changed the
and
greater
changed the
than
greater
to less
than to
than.
less than.
Okay. So what is it? Did you get the results the way you wanted?
Well, the first
Well,
one
the first one I wanted
the first
the
collation, I
first
wanted
policy
to
I
know
wanted to know
those
those
patients who
patients
have
who have
temperatures
temperatures
higher than
higher than
37.
37.
Okay. So did you get that?
That
Did you
one
get
I
That
had.
true,
one I
false,
had.
true and false?
Yeah.
Yeah.
Okay. Okay. Then, so I think this is what I wanted you people to do. You could have. Do you remember what we were doing yesterday? Like you could sample. I just want like where you can play with the things that we are doing, but I know from a start it may not be that easy. You can just sample. Let's say uh, you are sampling from 100 people, and you just want 30 of them. You just want 30. What is the 30 people? What is it from them? And then we are saying that what is the replacement? Or you are sampling from or what is it? Replacement is first. Okay, so okay, there's supposed to be comma here. Yeah. So we have just finished the sampling, and then we have our C and whatsoever which is there. But I want to find out whether the people we have sampled, is there anybody at all who is greater than 37 degrees Celsius? That person is, let's say, having higher temperature. So what I'm just going to do, I'm going to say here greater than 37. And then if I run the code, have you seen? Eben.
Yes, I'm here, please.
I'm sure you have forgotten of this from yesterday.
No, I want to understand what's going on, but I know the 100 is the population, 30 is the size.
Yes.
And then replace really
is force. And then 37 is the mark. And we are saying that if you have 37, you are all right, but above 37, you are not all right. So we can come here and then look at those who are, we can actually count those who are force. Those, how many people are, are having higher temperature, or the force will be higher. So I just wanted you to combine, you could have used any function at all to just, I didn't want you to write the figure that you already know, like 38, 39 or whatsoever. I wanted you to just throw the numbers at random, just like the way they have brought you a template, a very big template of people who temperatures have been recorded in it. So this 100 is different temperatures that have been recorded, and they have brought it to you. So you just decided to sample maybe 30 of them there, and you want to know how many of them are having temperature greater than 37. So you just write this simple code, and that's going to give you. So all those that turn true, it means or those people are having higher temperature. Those that turn false, they are the same people who are having lower temperatures, or anything below that.
But my issue is out of the 30, how do we know which ones have greater than 37 or below 37?
Okay, I'm getting to that. This one is just, we just threw some numbers at random. Okay, so if we wanted to know that, that's the second thing we are going to do here. If we want to know the individuals, the exact individuals who are having this, then we can go and use a data frame. Are you getting it? We can have a data frame of 30 people. We can create a data frame of 30 people, and then we can use this to be able to identify who and who are there.
Okay.
So if it were a data frame, or maybe I should just maybe I could just leave this out, and then I can just come here and say, let's say that's a variable 1, and then I'm just going to leave that as a data frame. Then I could come here, and then, so there are 30 people. I think I should reduce it because I'm going to use a particular function. Let me reduce it to 20 people for a reason. I want to use the alphabet to be fast. So our variable 2 is going to be something like this. And what are we going to do? We are going to use letters. And so we're going to use capital letters. And then how many of the capital letters do we need? We want from A up to the 20th alphabet. And then we're going to pack that into that particular variable. So I'm going to run the 2 codes. All right. So now when I come, I'm not going to do my data. I'll just give anything my D, or let me just say temperature. That's the variable name, and then come here. But I want it in a data frame. So I'm going to say data.frame. That's going to come there. So the first one will be my, the variables I should have, this variable one. So my data frame, the first one should be my variable one, and the second one should be the variable. Okay. That's all. So when you come, I'm now going to run all of them. You see that all of them run properly. Now when you print the temperature, it's going to be a data frame. Have you seen the data frame over there? Are you getting it?
Yeah.
Great. Now, okay, now if you are getting it, I didn't do this in the data frame, or I don't know whether I didn't teach how to be able to add a column to a data frame. Now, opportunity for me to teach to just show you how that is done. So now we want to find out who and who are having a temperature greater than 37, right? From that particular data set, from what we have printed. So I will now come and say, let's say high temperatures, or high temperature or something like that. And then how do I do that? I'm just going to say, where is the temperature? This is the data frame, the temperature. So come and indicate the data frame here, 10. Okay, the data frame comes there, but you're not looking for everything. You are looking for only the second column, right? We are looking for the second column, and so the second column, and so the second column is where you have the temperatures or the figures. So you want to find out those that are they greater than 37? So I'm going to write the 37 and run. So now if I come, it has printed the results into this. Okay, so all these true false are now found in the high temperature. So I'm now going to do the new data frame, which is term2, and then I'm now going to say that's a new variable. Do this and come there.
Data frame.
You see, when you do a data frame like this, I mean, you see that the names of the columns come. Now, if you want a new column, you come down here and say that, and give the name of that column. So the name of that column is, let's say, temperature measurement. Your temperature or temperature reading. That's a new column you want to add to the data frame that was already there. And where is that particular new data or that particular column you want to add? That column is the results you have here, which you have packed it into this. So this variable is what we want. So we now say we are packing that variable called high temp into it. So I run it. So now when I do that, and I now go to print temperature, if I now come to print temperature, I will now have 3 different columns. Each column will now be telling me which person has this temperature and whether it is high or it is low. So if I do like this, the temp is there. Now if I run it, you will see that. Now let me fold it up and you see. Now can you see? Hello? Oh, Eben. Paulina.
Yeah.
Can you do you get it?
I followed where you did it. Stop setting. Number one.
Okay. Okay. So
One second.
Eben. The gentleman's network is worrying him today.
My network is bad. I don't know.
Yeah, that's what I was suffering from yesterday. Okay, let me explain what I've done here. First of all, I decided to create. I'm just assuming that I'm working in a hospital, and then nurses brought me different temperature they have recorded in the sheet, 100 of them. So I decided to check, to just sample at random 20 of them. So that's what I have done here. I sampled 20 of them there, and I put it in this thing called variable. In fact, I could have called it temperatures. Then I came back, and then the names of the people are given to me, and then this one. But in this case, we didn't have the names of the people, so I decided to create A, B, C, D to represent the names of the people. So, and I'm sampling 20 people temperature, so I have to also create 20 random names. To create 20 random names simply, just do what we call letters and do 1:20 to create A, B, C, D up to 20. So I put that into this variable called variable 1. Now, I now need to form a data frame of this variable 1, which represents the names of the people, and then their temperatures, which is here. Now, after I have done that in the form of a data frame. Now, I want to calculate from that particular data frame which of them there has higher temperature and who has lower temperature. So I decided to create a variable name called high temperature. And then to be able to know who are having the higher temperatures, then I pick up the data frame, bring my square bracket like I want to do subsetting, locate the column that has the temperature readings, which is column 2. That's why I have column 2 here. And I want to find out if that column 2, there are numbers that are greater than 37. That's all that I have done here. And if the results come, everything should be packed into high temperature. And then I printed the results, I packed the results into high temperature. Now, when I came, the data frame was already called temp. So all I need to know, I need to add something we call adding column to a data frame. To add a column to a data frame, you bring the name of the data frame, then bring a $sign, then write the new name that you want to add as a column to the data frame. And then now the variable that you want it to come and be the new column, pack that variable into it. And in this case, this is the variable we want to pack into it is the high temperature reading that we have calculated. So we now decided to pack that high temperature into this new column, which we have created with the temperature data frame. So now when we print the temperature, the data frame, which I named it temp, then we should have our results. And we now know that these are the individuals who have higher temperature, lower temperature, and in that order.
That's good.
Right. I didn't mention this yesterday, but I was thinking that I was going to put that together as an assignment, and this gentleman managed to. What did you know? When we were in secondary school, we had these smart guys who will make sure that the assignment that the teacher wants to give to you, they will ask questions around that assignment. So the teacher, by the time the teacher will finish, he has already finished answering all the questions. So no, all right. Okay, so another way of conditional statement is something that you could cross-check. Like it's like you are using one condition to find out what another condition is there. So I've created something here like region. I mean, listen to this thing very carefully. It's confusing. We know the regions in Ghana. I have northern, upper, east, and whatsoever here. The towns in the region, they are all here. Now, I could try to find out if if I decide to isolate just the region alone, when you bring a square bracket, you can actually put a value in the square bracket to find out if it is true or it is not true. So if I put here region, I could also bring the curly bracket, the square bracket here, and I want to find out within the region, is there, this is what I want to, it's a bit confusing. Please, I beg you, pay attention. I am using one place to go and find out something, a relative. This thing, we call it match and indexing. So what I want to do is, I am actually using the region to bring my square bracket, but I will come and use town to find out the equivalent. So the town is Tamale, so the region should be what? Northern region. So if I come and run the whole of this, and then I come here to run, it's not going to print. I want to find out. So within the town, if the town is equal to Tamale, what does Tamale represent in the region? That's why I started with a region, but I'm using town to find out which particular town is related to the region of this. So when I do that, if I run it, it will print Northern region. Now, if I come here, that one there is just the region, and I want to print all those that are true. If I say that, it means it will print everything here. If I say false, it will print 0. Now, let me say this before, maybe that's what may be confusing. In the series data set, we can also do subsetting. For instance, if I have a vector like this, if I have a vector of let's say 30 is to 100. If I print it like this, and I want to be able to pick up the middle numbers here, I could just bring the name of the variable and bring the square bracket again. So if I say 6, it's going to print the CIF value. You get it? It's going to print the CIF value. Now, if I do 6 to 10, it's going to print from the CIF value to the 10th value. And that's how it is. Now, it's the same strategy I am using here. So, but in this case, I am doing cross-referencing. I have region, I have town. And then, because R is using indexing, the first name here, which is called Northern region, corresponds to Tamale. Asante region corresponds to Kumasi. So, if I want to find out which particular region corresponds to Northern region, I could actually come and then use the region as my basis, and then say for the indexing, let me pick town and say I want any town that is called Tamale. What is the corresponding Tamale in the region? It will give me Northern region. Okay. So the question that Eben asked earlier, we could have used this same strategy to be able to know who and who are having higher temperature and lower temperature. Do you understand? And will you want to try? Hey,
yes.
Okay. So now let's maintain this, and let's say something on top here. Let's assume that we were having some temperature readings there. So let me call that temperature reading. And then I just created, I'm just going to create a vector over there, and then just indicate some few values there. So let's say I have some values of 20, and then 30, 40, 50. How many are they? 1, 2, 3, 4, 5. 1, 2, 3, 4. And then let me just put 60. I think I've omitted something here. Okay. All right, so if I had run it like this, and now if I come here and I want to know, let's assume that Tamale is a name of a person. Okay, so if I come and change this to temperature reading, and I want to know who is that person that was having that particular corresponding temperature reading, if I put here temp reading, you see that it prints 20. So I could give a condition. This part I didn't want to include it, but I thought that it will be okay. I'll leave that part for now. Maybe when we have done looping and other things, when we go forward, it will become clearer how to use indexing and matching to be able to relate two different variables. Okay, up to this point, any question? Because we are moving to the next segment. Okay, so now we've succeeded in looking at some few things about conditional statement up to this point. But conditional statement doesn't end there. We also have the second part that we are going to look at is if statement, else if statement, and else statement. That one, you declare a variable and you give a condition. If the condition is met, then execute a command. So in every if statement, the syntax is always like this. You begin with, you can have a variable declared already. So you are going to declare the variable, declare a variable. And the second thing is you now bring your if, and the if have to be followed with a condition. So it's always a bracket, then you bring your condition, and if the condition is true, then you come out with your curly bracket and then write your command. Then here you write your command. And if the condition is met, the command will be executed. That's basically how if statement is all about. Example, I've declared a variable called x is equal to 50. And I'm saying that if x is greater than or equal to 40, what should happen? X is equal to pass. So if I come and print x, it will print. So you highlight the whole thing, run it up to this point, and now when you come and run x alone, it tells me pass because x is greater than 40. Let me go back there, change it to 30. and then run the whole condition again, it will print only the 30. Are you getting what I'm saying? So this is what we do. It's like when I'm typing, it makes it quite open. That's why I always like doing the codes ahead of time. So this is what I'm saying. I have A, which I have declared a variable A, which is equal to, let's say, 30. Then I'll just come and say if, and in R, anytime you are typing something and the color changes blue, it's an inbuilt function. So immediately you say if, the next thing that follows if all the time, if, irrespective of where it is a condition. And the condition is always in a bracket. So if, then you come and do your shift and 9, this small bracket will open. Write the condition inside that particular place. And you are saying that if A is equal to, if A is greater than, well, let me put it that way, it's always better, is greater than 30, then you come out of that small condition. Then you bring your curly bracket. Then what should happen? When you bring the curly bracket, just press enter. This arrangement will come. The cursor will not come to, it will come and just be lying here. So if A is greater than 30, what should happen? We should say that, we can say A, whatever condition we give here, it will now work. We can say A is equal to, let's say, A plus 3. And then we have finished writing the whole statement. If A, we have given a condition to 30. And we are saying that if that condition, if A is greater than 30, we should say that A is equal to that same A plus 3. So if A is not greater than 30, okay, in this case, if I print, what will be the value for A? So in that case, run it. If I run it like this, if I come here and I print and I write A, I want to now print A. What do you think will be the value of A? Here.
It will.
Come again.
If A is greater than. No, it can't add.
Okay.
So if A is greater than, of which A is not greater than.
Okay, so let me run A and you see. It will print the exact A over here. Okay? But now let me change that A to 31. Come here, run the whole thing again. What do you think, if I run A now, what do you think will be the value? Eben.
Trying to run
because the condition is saying that if A is greater than 30, here, we should print A is equal to A plus 3. And so I now want to print A. What do you think will be the value of A? You people, I hope you are not.
It will be 34. It will be 34.
It should be 34. All right. So you see that it's 34. It should be 34. What is it? That is it. Okay. So when you give a condition like this, without adding what the other conditions, what happens is that if the condition is not met, it goes back to print the original value that you declared. So that's why if I come here and I put there 20, if I come to run the whole thing, it will print 20 because I cannot find the condition. You see, it will print 20. But anything I now do above 30, if I put, let's say, 34 here, then I come to run the whole thing, it should print 37. You see that it will print 37 because the condition is met. Are you all clear with this?
Yes, please.
Great. Now it's your turn. I want you to write an if statement to print that a value is an even number. Do you understand? To find out whether a value is an even number or not.
Which value?
Just take it again.
I'm saying, I want you to write an if a statement to find out whether a particular variable or a particular variable is an even number or an odd number. No, just an even number, because I haven't come to else if and stuff. You could just use this same code and change some things there. If you're not getting it, we can do it together. I don't know. It's like anytime we just come start now, the time we just be running unnecessarily. You get them?
I don't know how to write the even number.
Okay, I'm coming. Do you remember that I said if you want to find out whether a number is even or it is if you want to, I'm just okay. Let me wait for Eben and see what he too will get.
I'm coming.
Mm-hmm.
And get some.
I was responding to a message. Okay. We should do it together.
Yes.
Okay, thank you. So now I'm just going to copy this. Paste it here. Now we have A, which is equal to 34. So we want to find out whether that value 34 is an even number or not. Okay. So we will come down here and say A. So we'll come and say if A percentage, that's modulus 2. If we do this and then the result is 0, it means when we divide A, which we have assigned 34 to, if we divide A by 2 and the result is 0, it means A is what? A is an even number. A is equal to, then we come here and just change and say A is even number. So we print the whole thing and come and run it. You see what is there? A is even number. So let me change the 34 to 35. It will print A is equal to 35 because there's no else condition. You get it? But if I change to 32, I don't know, you people know math. Is 32 an even number? Yes, it's an even number because the condition is meeting. I'm sure the reason why you guys didn't get it was because I didn't tell you that this is modulus, and that's how we modulus means when you divide the remainder, like the way we used to do number base. When you divide a value, whatever that is remaining, then that becomes your modulus. And you see that when you divide any number and the result is 0, if you divide it by 2 and it is equal to 0, the remainder is 0. It means it's an even number. All right, so now do for odd number. Let me see. All the codes I'm writing here, I am going to keep them. That's what I'm going to use to build functions. So keep them, in proper position. We're going to use that one to build functions from tomorrow. How to write a very long function. And you see that it's not rocket science. It's just step-by-step things. The odd number, quick. Don't just type the whole thing. Just type, just so that you get used to typing mathematical this thing. Somebody's worrying me with plenty messages here. What is it? They've given the child fee paying.
Okay, I'm good.
Give the person admission.
Okay, I'm good.
Okay, you got the odd number?
Yes, please.
Great. Yes. Polynomial.
Yeah.
Have you gotten the odd number?
How do you write not equal to?
Sorry.
I have to get a
Shift. Press your shift key down and 5 twice. Your
shift key.
and then 5 twice. It's percentage. Is not any listen.
Is that symbol not equal to?
Is it a double equal or
No.
shift and
Inside
5?
where I'm supposed to write the command. I want the condition.
If So that's what I'm saying. It is called percentage. It's the ordinary percentage. Just do the percentage twice. That's all. So you can get that from shift and 5 on your computer. Have you gotten it?
I don't understand my. It's not
the question.
Yeah.
So you have if, then you open your bracket. Then you write. You write a percentage 2 equal 0 bracket close. Then you come and open your curly bracket. The curly bracket is the same place where you open your square bracket. So, but now in that case,
I don't want equal to. Because I want to make it odd. I just want to get a sign that says not equal to.
Okay. Then put exclamation mark, shift and 1 this way. Okay. I get you.
Still, I'm wrong.
Come again. Did you get it?
No, I didn't. Non-numeric argument to binary operator.
Non-numeric to binary operator.
Yeah.
How?
Maybe the exclamation mark is not used for numbers.
It's used. It's the condition. Yes. But I just did and it's working. For I mean, look at my screen well, and write it again.
Yeah, it was. Yeah, it was.
Yeah, it's part of the inbuilt functions, not equal to. Have you gotten it?
Just
Come again. Don't worry. If you're not getting it anywhere, let me know where you are not getting it. We'll pick it from there. Have you declared your variable? Like, let's say a is equals to like a number, any number.
yeah, I made that B is equals to 34.
Come to a new line.
Then the new line, if into bracket. Ah, stupid me. I still have the
Oh, look, what is it? I need a cane. I need, I need a cane. Okay.
That's
All right, then make that correction so that we have less than 20 minutes. We have less than
Yeah,
20 minutes, and I need to go and start cooking.
I've done that.
Um, so is it working now?
Yes.
Okay. Now we are moving to the next part. This one was just the if. What about if this condition is not met? What should happen? So you see that when the condition is not met, we force R to go back and print the original value. No, that should not be the case. So let me copy the whole of this. I'm going and then come and place it here. And I'm saying that A is equal to this. I declare a variable. I'm saying if A, this man, his network is worrying him. I don't know whether he's gone out. So if A modulus 2 is not equal to 0, then it is an odd number. What about if there's a different condition? So we can say, that's why we bring else. Hey, I cannot spell else. Ha. Nanado is the problem. So you bring else, and now let me now state this. Anytime you see if, what is following the if must be the condition. It might be the brackets. When you follow, if you see else, whatever follow else is the curly bracket. Now, what enters a curly bracket is a command. What enters the square bracket, the main bracket is a condition. Please get this, and you can write your if statement anyhow you want. What enters the curly bracket is your command. What enters the main bracket is the condition. And that condition must be met before the command is executed. So we gave the first condition. We declared a variable, A33. The first condition says that A modulus 2 is not equal to 0. If it is not equal to 0, then A is an odd number. Now we come to say else. If that condition is not met, else A is what? Else we can say A. We can say that A is equal to an even number or something. An even number. So now when we now run the whole condition, we run it again. It's an odd number. When we change it to 32, then we run it again. They say it's an even number. Now, do you get the difference? I mean, what is a prime number? I don't really know what that is. I've forgotten.
Bonus.
Come again.
Right now we're saying number.
All right, I'm going to leave that. That's going to be an assignment for today. So the first assignment, okay, first assignment. I'll copy the whole thing and then give to you. Assignment. I want you to write if statements or if else statements to print either to print a prime number. Please remember that you need to know what prime number is. You need to know which condition have to be satisfied so that you can be able to print a prime number. When you do that, you have no problem. That is the first assignment. Now let's move to this. Now we are done with the if and then the if else. Now let's go and look at, okay, those were the examples I've already given here. So you have now if I run this code, you see that the person has passed. That's also another way of writing a code to print exam results. You see, those who had aggregate days, you can write a whole R code to be able to do that. Okay, so that another one was here. I was saying that if you have A, you declare A 6. If A is greater than 10, we should say A is equal to, then you bring your mathematical formula. A is equal to A to the power of 2. Then it will print A for you. But if A is not up to that, it won't print. So here we could add if or else. Now I brought in another condition here. Now going a little bit extensive, we have declared something, vegetable type, which is equal to a tree. Then we have given the volume, which is equal to 2. And we are saying that if the vegetable type is equal to or is the same as this, that's where I was showing these conditions earlier. If the vegetable type is the same as 3, then we should print the mass. We should calculate the mass. And the mass will be equal to 2.6 times the volume square. So when we can print the mass. Alright? So the mass is printed. But because we have not given else, if we change the condition, if we change the 3 here to something else, it will still print the mass. Because it will go, arrow will go through and it won't find anything, so it will come and print only the equation. So if I come here and I change to, let's say, this, and I come to run the whole code again, you see that it will still go and print the equation here. Alright? But I'll show you where the equation will not work. So now I decided to do another one here. Member, then I declared, let's say, Paulina. I'm saying that if member is equal to Paulina, then we should say that the member is a female. Else, the member is a male. I was going to give this an assignment, but so now if I print it, it should say it's a female. Now let me change the name to Paul, and you see what will happen. If I change the name to Paul, and I come to, you say that Paul is a male. Right. Now, your second way of, your second analogy. Write if else statement if you are listening. And I want you to use this same strategy here. Declare the weight of yourself. So your name, like Eben, then your weight, or Eben is equal to, let's say, weight. Okay? And then you can say your height is equal to 2. And then you come and say that if Eben is equal to weight, then what will be his BMI? Then you know how to calculate BMI. And then return the BMI for me. BMI is equal to, is it weight over height times something? I've forgotten. Weight over height times. Somebody is sending me a WhatsApp message. Oh, Eben, he has gone off. His network is not good. Oh, sorry about that.
Let me hope and see if I can continue.
All right. Did you hear the instructions I gave?
No.
Paulinho, I was saying that we have declared. Okay, now let me do one. Let me do one together and let's all see. So let's say I have I'm just going to say, okay, I have what, Paulina, and I'm declaring something. So Paulina is equal to, let's say, a lady. And I'm saying that what we are thinking that ladies are shorter comparatively. So we say, I'm declaring another variable called height. Height. And then I'm saying that the height is equal to, let's say, 4 meters. I know you're not up to 4 meters, but no problem. So I'm going to say if, okay, where am I? Okay. So I'm going to say if, all right, then I bring the condition. The condition is that I'm saying that if the condition, and I'm going to bring here, say, Paulina is equal to a lady. First, if I do this, a lady, then we go out of the condition, press shift and your square bracket, so the curly bracket will come. Just do enter. It will just make this arrangement for you. Then we should say that what is it? Paulina height is equal to, let's say, 2 times, or no, let me say 1 point something, 1.2 times HTT. So if I come here and then I write, if I put Paulina there, it should be able to calculate the actual height. There is an object somewhere. Yeah, it's here. Great. This place, I didn't declare, it was a text, so it has to be in double quotes. So now, if I come here, you see that it has calculated Paulina's height. It's 4.8. But it has only calculated the height because Paulina is a lady. If we change it into a guy, what is it? It won't calculate the height. But this can only work if we add else here. That's what I wanted you guys to do. So we could have said else. Then once you bring else, you bring your curly bracket again and open. Else we could say
Object coordinate found. Uh,
That's all. So if I do that, it will calculate. If I change this lady to a different thing, small l, let me do everything and say what will happen. They say that it's not available. So just get practicing with these things, add mathematical operations and whatsoever to it, and that's it. Okay, so I think I should be doing the last parts. This is the very last parts that we are going to do. I've already shown you this. I will copy the whole thing. I'll give you the whole thing. So if it's not available, now let's look for this very last part, the last one. So I have a vegetable type, which there are some of them are grasses, some are trees. And so I declare that the volume is 2. And I bring a condition and I say if the vegetable type is the same as tree, then we should calculate that the mass, the measurement of the vegetable should be calculated using this particular formula. 2.6 times the volume square. Volume has already been declared here. And I'm saying if the vegetable type 2 is also not grass but a different vegetable, then you do another condition which we call the else if. So because you have brought if here, what should follow should be a condition before the command. Else if the vegetable type is equal to grass, we can say that the mass should be 3 times the volume. We can do another else if. We can do the else if and bring all the conditions. And then, but at the last part, we just bring only else. So I decided to use just 2. So I could say else, we can say the mass is not available. That's how it is. So if I run this, the whole of this, you say the mass is 6. It means that it's grass. If I change the grass here to 3, and then I come and run the whole thing, it will calculate only the condition. You see that it's 10.4. It will go through the loop and find out that this is the only condition that is meeting here. So it will calculate this particular one because this condition is not met. So this is where the condition is. Any more question up to this point? If you want, when I send you all the codes, you could have copy this and do something. I'm just going to paste this here, and then in that case I could have added additional condition here and say that else if, then in that case I have to bring a square bracket here, and then inside the square bracket I write another condition. Another condition is saying that if the vegetable type is equal to flower, is the same thing as, let's say, flower, then the condition should be that the mass should be calculated as or we should say that we can just give a condition here and say we can't calculate. All right, then that's what is it. That's all. We can come here and say now bring our else. Then we bring only the curly bracket and say if all the conditions are not met, then we can say our mass, this particular mass, we can say is equal to NA. You see that I don't put NA in double quote because NA is this thing. NA is an inbuilt function, so you don't need to put it in there. So you see that now, if I run, if you highlight the whole thing and run, it's 10.4. If I go there and change it to flower, if I change the condition to flower, all right, then I come to run the whole thing, it should tell me that we can't calculate. You see that it comes here and tells us that we cannot calculate. So whatever condition you give, you come out with what should come out if that condition is met. So now let me say this very last. All the apps that we are seeing on mobile phones and stuff, this is how the programs are written. So what you don't see is, you don't see the rest of this code. This could have been a small checkbox somewhere. So when you put flower there, this particular result will come. When you put tree there, this result will come. This is, okay, I'm not going to jump the gun, but this is the systematic way to how codes are run, and then apps are being built. You run with all these conditions, all this code, and when you finished, there is a platform that will allow you to convert it, and then it becomes an app. So, well, small, we are going somewhere. So that has been our discussion for today. Is 2 minutes to 5, and somebody will have to start cooking.
Wow. Thank you.
Thank you very much too. I'll send you the code very soon.